Hey guys, so as you'll have seen from my last video on the infrared robot hoover controller, I'm starting to move more and more into Home Assistant. Part of what I want to do with that project is to be able to control the temperatures in the different rooms in the house, and a key component of that is measuring the temperature. So I've been looking at different solutions and just what I had in the components drawer, and one thing I was looking at using is some of these cheap ESP01 temperature hookup modules which I purchased some time ago. Now these are just based on the Dallas temperature sensor, and that is tolerant, I think, to believe plus minus 0.5 degrees, which is not too bad. I originally thought it was a lot worse, but it's okay. It's got a small linear voltage regulator on there which can take up to 5 volts and deliver up to about 150 milliamps, and it's just fed in via these 2 pins here. And you can use whatever power source you want. I would probably recommend you go for a LiPo battery, and this is something I reclaimed from an old laptop pack. I would recommend, if you're using a LiPo battery, that you maybe use a protected cell, and if you need to, you can get small conversion kits. Andrea Spees did a really good video on configuring one of these, so I'll link his video down below. If you're going to use AA's, I wouldn't recommend using the 2-cell holder. At best, with non-rechargeables, you're going to get about 3 volts, which is right on the lower limit already. And the ESP will function when it's slightly lower, but you're going to run into issues and brownouts and stuff. So if you are going to use AA's, I'd recommend using one of the 4-cell holders, which with rechargeables, which is advisable, that's going to give you about 4.8 volts. So that would be my recommendation. The sensor is pretty basic. It hooks up the Dallas sensor to GPIO2. There's a small button which is hooked up to the reset pin, which is going to allow you to reboot the device, and that's largely it, to be honest. A few other surface mount components. So it's a case of flashing your ESP01, then you can just pop that straight into there, and bar power, that's your sensor done. Now, one thing that I did observe is that it's not the greatest placement of the sensor, in that it's sitting right below where the ESP01 is, and that's going to potentially skew your temperatures a little bit. So one thing I did do to mitigate that is to insulate it slightly while still leaving one side fully exposed, and it insulated it from the ESP slightly. Most of the heat is radiated from the bottom here. Didn't cause any issues with the ESP, and it just made the temperature readings bit more reliable. For battery powering, one major obstacle is that the deep sleep mode of the ESP01 doesn't work out of the box. In the respect, well, it works, it'll go into deep sleep, but it won't come back out. So one thing you need to do is to hook up a small wire. Now this requires some really fine soldering, and you'll see there's a single strand of wire which goes to this pin right on the corner at the top there, which is the XPD pin, to the reset pin on the ESP01. I've left that bare at the moment, but I will put some hot glue or similar on just to stop that touching the other pins, but just so you could see. And with that modification, that allows you to put it into deep sleep. And then in your software, you can tell it to go into deep sleep and how often it should come out to measure the temperature. And so your battery life will be dictated by how frequent you want to measure those temperatures. Now, the main advantage of this is that, as the title suggests, it's about $2 all in, which is fantastic. There are other variants which use the DHT11 or the DHT22, which would be preferable. I'm not sure if there's one for the EMS2320 chip, but that is a good chip as well. But yeah, it's hard to argue at like $2 or £2 for something like this, and I would love to use the Yaml sensors or some other kind of sensor, but you're looking at nearly £10 each, and then there's things that you need to do for BLE and all this kind of stuff. This is just still using Wi-Fi, and it's great. So similar to the IR robot hoover, I'm going to use ESPHome, and there's a couple of little caveats and tweaks you can do with that. So what I'll do is I'll switch back to the computer on the desk, and we'll have a look at the code. So we're in ESPHome here, and I'm not going to jump into the configuration of how we add things because we touched on that last time, so you can see my previous video. But if we go into edit here, and what we're going to see is, as we previously had, you've got the ESPHome declaration at the top, you've got the name, the platform. This time we're using an ESP01 module. Only the 1 meg module is supported, I believe. You can retrofit the memory onto the modules. I have an earlier video which I'll link to show that. You've got your Wi-Fi configuration, you've got logger, API, and you want to use the over-the-air update facility. So as a first step, what you're going to require when you're using the first sensor is that is all you need initially. And then what that's going to do is you upload that code as we touched on previously, and then you check the logs, and then if your pin assignment is correct, so in this case we're using GPIO02, it's going to list what Dallas sensors are on that GPIO, and it will tell you the sensor, and it would also give you the address of that sensor. So if you have multiple ones on there, you'll be able to see. But once you've ran that, you will hopefully find a Dallas sensor and the address. So then we can add in the sensor, and then we will declare it as platform Dallas, the address that we previously found. I'm going to put a name on there. We want to put a filter on just to try and calibrate the sensor, and then there's two different ways of doing that. Firstly, you could just do an offset. So if I uncomment that, that would subtract 5 degrees from any reading that we get. The issue with doing this is that you may see that it's, say, 5 degrees off in the value I've got there. But what you'll probably find is that as the temperature changes, that offset's going to be incorrect. So a better way to do that is to use a linear calibration. What you're going to need is a known good temperature reading, and I'm going to use my Hive temperature sensor. And so what I did was I put that next to the DIY sensor, just left it to settle down so they're in the same location, same airspace, and then on reading the DIY sensor it was 22.8, and then at the time my Hive sensor was reading 20.7. So we put those two sensor readings into the calibrate linear function, and then what that means is as the temperature increases or decreases, it's going to work out what the difference would be in a linear fashion, and then it'll apply that differential. So it'll be a bit more accurate. You'll find it's difficult to get it exactly spot on because the two different temperature sensor types, different accuracy, but that was pretty accurate for me and that worked quite well. I wouldn't bother with the ADC for the VCC voltage measurement, that didn't work very well. The most important part for the battery life is the deep sleep. So there's two parts to this. There's the run duration. So I've currently got mine set at 6 seconds. And that 6 seconds is actual run time of the code, which is separate from the boot up time, the time it takes to acquire Wi-Fi, and any other functions that's going on with ESPHome. So that's going to actual run time of 6 seconds. And I've went for that because I've set the interval update for 5 seconds. So with an update interval of 5 seconds, that means we should get at least 1, if not 2 potential readings. I did previously have the runtime duration set to 15 seconds, and that was giving me 3 readings, but that's not really necessary. So with 6 seconds I should get 1 good reading, and then that'll be read into the software and sent to HA. The next important part is the sleep duration. This is going to determine how long your battery is going to last. The more often you wake up to take a reading, the more power you're going to use and the quicker you're going to run your battery down. I'd guess you're probably going to get about 6 months worth if you're waking up between every 5 and 10 minutes. That might not be accurate enough, so you might want to increase that. I've got this set at 2 minutes here for testing, but you can play with that, and then it depends on how you're powering it as well. And that's the configuration. One important thing to remember is that when the module is in deep sleep, the radio isn't active, so it's not going to be able to send any readings back, and you also won't be able to communicate it. So what you will see is that every 2 minutes, in my case, the office temp sensor will come online, send a reading, and then go back offline, and this will be updated here. So when you would do show logs, when it goes through its cycle, you would see that pop up there, and it'll send its reading back, and then you'd see it disappear again. So the only disadvantage there is that if you want to upload new code, or if you want to upgrade to a new version of ESPHome because it's updated regularly, it's a bit of a pain, so you might just have to do the compile, download the binary and upload it as we showed in the previous video. So that's the only downside, but that's the trade-off of having it battery powered. So that's your configuration. So we can add it into Home Assistant as we've done previously, and then we can create a small graph there which shows the temperature, and we can also do this to be color coordinated, so the higher it gets it goes to red, lower it goes to green. And yeah, there you go, that's a temperature. In case anyone comments, the upstairs heating is different from the office temperature, so that accounts for the degree difference there. But generally, if I've had the two sensors back to each other, next to each other, the Hive and the DIY sensor, it's generally within about half a degree, something like that, so it's not too bad, it's usable. So thanks for watching, guys. Feel free to like, subscribe, and catch you later.